Geography and You presents
Welcome back to the GNY Live podcast series on the air we fear. Today we explore the hidden dangers of air pollution. Not only is it toxic to humans, it impacts faraway places, even high up in the Himalayan glaciers. I am Hiteshika, your host. We are joined today by our discussant, Dr. Sulagna Chattopadhyay, Editor in Chief, Geography and You, and our guest speaker, a renowned geologist, recently retired from University of Delhi, Professor Naresh Chandra Pant. Professor Pant has published over 100 research papers including glaciers, global climate systems, and mentored numerous eminent scientists. As a young person, I often reflect on the world we are inheriting and the responsibility we share to tackle challenges like air pollution and climate change. These issues demand not just awareness, but meaningful action. I am hoping that today's discussion will throw light on what we can do to be the change. With that, I am eager to pass the conversation over to Dr. Sulagna Chattopadhyay, who will charter our discussion through this critical issue. Over to you, Dr. Chattopadhyay.
Thank you, Hiteshika. And true, we really depend on people like you to be the change and bring the change to the world that we now currently inhabit, which is seeing so many different kinds of problems. Professor, it's wonderful to see you. It has been a long time. We haven't met in person for a very long time. And you have recently shifted back to Delhi from Gandhinagar. So, do you see any difference? How is the air here, sir?
Well, first thing, it is very cold here these days. And of course, on a serious note, the air is definitely much more populated than it is there at Gandhinagar. It is loaded.
Populated, you say?
Yes. And this loading is actually of concern. So, yes, there is a difference. And hopefully for people like Hiteshika, who are young and who have to live longer, we can start thinking how it can be unloaded a little bit.
Yes, that is important, sir. And that is why we are all here today. And we have been bringing this up in all the podcasts that we are doing, that we need to understand it from different perspectives and try to bring out something which we can do. Professor, let us start with something interesting, a term that you've used in your book on the Himalayan glaciers. You have called it the third pole. This is the Tibetan Plateau and the Himalayan region that you referred to
Yes.
as the third pole. What do you mean by a third pole?
Well, actually, the term pole, in the context in which we are talking today, refers to high latitudes, basically. That is very close to the geographic North Pole and geographic South Pole. So when we talk of Himalaya as third pole, it actually doesn't compare in terms of many characteristics, like it is definitely at a much lower latitude. The one thing which make us talk about it being the third pole is the presence of ice. However, even in that context, it is very small component. For example, in Antarctica there is 30 million cubic kilometer of ice, and in Himalaya, with best estimates, or talk of 7,000 kilometer cube. So there is a vast difference. However, the way this ice impacts a large population, and I can safely say 1/6 of the global population, makes it very important. And in that context, it is very appropriate to call it the third pole because it affects us in the similar way for a much larger population. So the presence of ice and the effect on the population or the large population makes it relevant to call it third pole.
Okay. So it is not one thing, but two things combined together that makes it important for us to understand it as a
Yes.
pole. Professor, now, we live in the plains, and you have worked in these high mountain areas up in the glaciers. And so you think whatever we do here in the plains, whatever we burn or the fossil fuels, etc., and you've worked for 40 years on issues such as this, you think these kind of things can reach far, mighty Himalayas and up in the glaciers. So whatever we are doing here, I mean, it seems impossible that how you can. And to add to that, you have been officiating at SCAR. SCAR is SCAR, that is the Scientific Committee on Antarctic Research, and you have been part of that also. You have one of the very few scientists who have had the opportunity to visit in the early part when we were establishing our Antarctic program, and you worked on the geology of Antarctic. But can dirty air, I mean, we are hearing reports about dirty air reaching Antarctic. I mean, are you sure, Professor?
It is actually a very good question, in the sense that what is that which makes us live is also something which travels far and wide. That is the air. I mean, atmosphere has many layers. The one layer which affects or impacts us a lot is stratosphere, which ranges from 6 to 12 kilometers below and up to 50 kilometers. And in that, the things which we do in equator or close to equator can reach even up to very high latitudes. So it is in terms of horizontal travel, it can travel to a great distance. And similarly, in terms of vertical travel, it can go, say, for example, Tibetan Plateau is 4,000 meters and above, that sort of height, elevations. Yes, so it can travel there. And there are very solid evidence of showing that it occurs and it can impact the life in many ways. I'm not being very technical in terms of cloud formation, in terms of illnesses, in terms of carrying material, but it can impact tremendously, yes.
So it can move through the atmosphere to all these faraway places.
Yes.
So how? Through winds? How does it?
Yes, through air which circulates in patterns which are governed by many things, including Earth's rotation, including temperature variation, including the space weather, that is the way the space beyond Earth affects its weather. So there are many of these things which combine together. It is, of course, a very complex interplay. Mm-hmm. And we should not forget that. But at the same time, the effects are something which are felt by every one of us in different ways. Like what you mentioned in the beginning, the way the air is more loaded around Delhi and less loaded around Gandhinagar, let us say. So in that sense, so it is all because of the differences in the way the air travels and the way it carries material, especially one kind of material which are called as aerosols.
Okay.
We can talk about aerosols because that affects us in many ways. They are basically very fine particles, normally less than 1 micron, which is 1,000th of a millimeter. And they are not only solid particles, they could be liquid droplets also.
Okay. So yeah, that is I would request you to really expand on that, because now my vision of Kalidas is Meghdut with all the beautiful white clouds, and it's clouded actually, to put it that way. I'm shocked that, we can have this kind of dirt that can ride the air, and like, you said Antarctic also. So what is the composition of this dirt really? Aerosol is one of these components, and can you expand a little bit and tell us what is aerosol? But I thought aerosol also helps us cause rain, and isn't it also important to have aerosol?
Yes.
So how is it bad?
True. Aerosol impacts the cloud formation. It can impact, let me give you one example. of, first of all, how far it can travel. So if there is a volcanic eruption somewhere, let us say in Italy or in Indonesia currently, for example, that material will go out. Some material will be fine enough in the size range of what we call as aerosols. So those dust particles, etc., will go up. Along with whenever there is a volcanic explosion, there is also some gases which come out. So there could be sulfur dioxide droplets, fine droplets, which can go up also. Now, if their concentration increases at higher level, at few kilometers above Earth's surface, then the sun's rays will be reflected back from them. So the heat will not be stored, and that will lead to a cooling in that area, right? So similarly, all kinds of dust particles from natural or man-made or human or anthropogenic sources can impact the cloud formation. In some cases, it can increase the cloud formation, storm cloud formation. In some cases, it can decrease, right? So the natural causes are something which we can't do much about.
Yeah, right.
But the anthropogenic causes are those which we can, which is something where what Hiteshika mentioned or his future life is concerned, how that is going to change is going to impact us.
Professor. Now, just to talk a little bit about glaciers, so there are reports of this pinhead-sized holes to even golf ball-sized holes on the surface of these glaciers. It is said that filthy air is causing this. Is that true? And are these holes making these shiny glaciers black? And just like our black deposits in our lungs, we had Dr. Arvind Kumar coming in, and he talked about how our lungs are turning black because of the pollution in Delhi. And we all have smokers' lungs. So just like humans, are the glaciers also falling ill, and are they also dying or melting, as it's popularly known?
It's a good analogy, actually. So these holes which you mentioned, they are called as cryoconites. And they have very similar characteristics. It's surprising that the ice on Himalaya, on Tibet, in Antarctica, in Arctic, everywhere these are present. So initially it was thought that they do not matter much, but we find them everywhere, and the study has evolved in a different context. I'll just explain, take a minute to talk about that. But essentially they are circular, and they are like cylinders. At the bottom of the cylinder there are sediments.
Okay.
So in pristine white ice in Antarctica, let us say, you have these circulars, and then there is now these particles, these sediments are essentially those which have been carried by winds most of the time, especially in those far off places. Now we can characterize those sediments. The way the cryoconites have become important is that they have led to an ecosystem which is typical to them. So there is a biological activity also associated.
Okay.
So that is a new direction in which a lot of work has been done. So it is not only the mere presence, not only the health of the glacier, but also the way the biosphere is getting impacted or developed because of these dust particles which are carried from far off places in the cryoconite holes. They are, of course, wherever these sediments are there, so they are darker in color, and this ice is white. So therefore the difference in reflection of the sunlight comes up, and more retention of more heat is there. So they are also affecting the life of the glacier.
So do we see an increase in the climate change scenario? Are we seeing an increase in the number of these pinhead-like holes on the glacier?
Okay. This is the place where I start humming and saying that maybe the problems. The problem is not in the process, understanding of the process. The problem is in this good with less errors data about these. So the definitely these actions are happening, but how much they are impacting is something which is where there is a variance. So latest study actually by our PRL group and some other scientists, they indicated that the global warming context from the dust particles, I'm not talking about cryoconites, but about the aerosols.
Okay.
The aerosols may be warming, contributing to half of the warming. You and me, we are very, or Hitashika, they are young, intelligent people. They understand carbon dioxide.
Yes.
So, and that is what we consider as the main problem and try to restrict that. But these studies indicate that about 50% of the global warming in our domain, that is Indo-Gangetic Plains, the Himalayas and the Tibetan Plateau, is possibly because of these aerosols. Now the thing is this, that the way these studies are done, there are three modes or methods. One is actual observation of the particles, etc., aerosols, etc. The other is using remote sensing for these, like MODIS and other. And the third is modeling.
Okay.
So, and modeling normally involves some data and rest projection using, physics and other things. But in all these, the errors are still significantly high.
Okay.
So that is what I meant when I said that we cannot be very definite. Though the deleterious effect is there, but the quantum or quantity of that effect requires more science or more observation or more of combination of these three methods.
But we're definitely sure that, in your, like you said, in the Tibetan Plateau and in the Himalayan glaciers, dust or aerosol is a significant component for warming of these.
Yes. That is decidedly the opinion and the right current opinion about this.
Right, Professor. Now, moving on, that brings me to a very important question, something that we've been struggling for decades now. We have, like you said, very confused science or many kinds of projections. So are the Himalayan glaciers dying? And what would happen to our rivers? Would they be drying? And is the air anywhere connected to all of this?
So aerosols are definitely connected to that, no doubt about that. We talk of man-made anthropogenic sources and the natural sources. They are there, black carbon, brown carbon, air, etc. The one more thing, if we can, we can reflect back, is that, we have multiplied faster than anything else on this planet.
Okay.
So if we consider the Iron Age, etc., we were possibly 500,000, whatever best estimates are there. We are right now 8 billion, so, or maybe more. So the thing is this, the effect which each one of us impacts, like for example, we are sitting in this place, we have changed the ecosystem by constructing houses or this studio, or change it in the way in which other animals don't do. So we have multiplied very fast, that is grown very fast, as well as we have changed the ecosystem significantly. So we have added to the factors which impact the climate in a significant way. So this combined with overall global warming, because the carbon dioxide and aerosol both are getting added because of anthropogenic regions also, besides the natural reasons. So because of this, the cryosphere or the frozen water part of the Himalayas, most of the glaciers are receding. 75% of the Himalayan glaciers are receding.
75?
Yes. So it is there are, if you look at the major river basins in India, there are about 22 major river basins classified. But the three big ones are the Ganges, the Indus on the west, Ganges in the center, and Brahmaputra. And they are huge, and they are actually across several countries. Now, these affect about 1.4 to 1.5 billion people, not only in India, but in other. So, in those, the water supply, especially for all kinds of purposes, energy, agriculture, etc., is affected. However, it is not that the entire water is coming from the glacier melting. For example, towards west, the glacier component is higher. Towards center and towards east, it is much lower. So it is not that if the glaciers totally recede, the rivers will totally get dried up. As an overall picture, that is correct. But the communities, and I think you understand that much better than I do, the communities which are dependent, the smaller units which are individuals, they are going to get affected by the changes in that water supply, which is dependent upon the melting of the snow and ice.
So, but in that context, Punjab would be more impacted than Arunachal. That's what you're saying?
Yes, definitely. And also, it is not going to be a one-directional change. It will not be a vector. The change may lead to initial higher precipitation and then decreased supply. So it may be that initially there is a higher water supply because the precipitation has become higher.
Become more.
Yes.
So, sir, before we end this on a serious note, Professor, as a geologist and a leader in scientific research, what are the solutions you really propose for this growing problem that we are seeing, which, as you have pointed out in today's very eye-opening podcast, that it's impacting the glaciers as well. So what do you think, what would be a 3-point, 4-point solution?
Yes,
for this?
actually I have a 3-point solution.
Okay.
So the 3-point solution, if it can be summed up in one phrase, is sustainable living. I know it's a very often used term. It has lost its meaning because of that reason. But if I break it down into 3 things, so one will be good science. For example, where I am saying the errors are more. Why? Because if we, like anything else, if the diagnosis is good, the treatment will always be better. So that is one thing. Second is that with every kind of approach, and I call that as an extension of sustainable living, we need to reduce pollution. And this pollution is in terms of both, as I said, the greenhouse gases as well as aerosols. And this can come about if there is a comprehensive thinking, then only it can come about.
Correct.
So even when we spray pesticides, that adds to aerosol.
Yes.
Thing. So everything has to be in that consonance. And the third will be actually, besides good science, that if we are able to contain our numbers, in my opinion, because that I think is an overriding issue and problem. The word is actually doing that, or the word on a bigger scale is doing that, because then only you can have a box in which certain volume is there, but you cannot fit in much more than that volume. So that I believe it's a
tricky thing you're saying,
it's a tricky thing, yes.
Because,
but it is something which is very important.
Yeah, but I think our fertility rates are definitely dropping.
Yes.
It's declining, but of course the pace of that decline is it's slow. But then it's a downward graph.
Yes.
So hopefully a few more pandemics and we'll be we'll be on track. But no, that was on a lighter note. Of course not. But yes, I agree that we are we are too many. But also management, I feel, is another issue that we don't really manage. What do you feel about the management aspect of...
I have very strong opinion about that, actually. In India especially, when you compare many of the developed societies and us, our lateral interactions are very restricted. So we each one of us, whether we do science or whether we do administration or whether we do planning, the lateral interaction is very limited. That is one big flaw in our thinking. So I believe more expert interaction rather than more bureaucrat interaction will be one good solution. And second thing is equally important, and I have as the hairs are keep on going grey, I've realized that the participation of the communities, which are the major stakeholders
Absolutely.
in every action to be planned, that is what is
Absolutely.
essentially needed.
Essentially, because that's what our other speakers, eminent speakers, also pointed out, saying that people have to. The issue has to resonate with the people. So if I'm coming to the people and telling them that this is a problem, they should understand it as a problem.
Yeah,
So for that,
Sulagna ji, I will just give one example.
Yes,
For example,
yes.
In case of in aerosols, the dust particles are there. So man-made dust particles come from mining, let us say. So there is a big problem in our neighboring area, Rajasthan, Haryana, of silicosis. Again, that is connected with lung
Lungs.
and air. But it could have been easily resolved by having a mining way which is wet mining rather than too much of a dry mining.
Okay.
Its impact could have been reduced tremendously.
I see.
But the people who are there, they are, for them the priority is to get livelihood. That is correct. So they are involved there in those small mining. But if they know, if they empathetic with the sympathy, if they know, they will realize that this mining can be in a different way with slight cost addition, not much, but it can be much beneficial to them in terms of their health and other benefits.
Yes, that's a fantastic example. But this actually shows the gap between, knowledge, wisdom, and of course action. So thank you, Professor. It was wonderful to have you, Professor. This discussion was indeed eye-opening, and that's the least. I mean, there is more to come. I mean, we will have you over for several other discussions. The next one that we are planning on Aravalli. I mean, Aravalli, of course, as you're a geologist, so you know what's happening there. So it's almost wiped out. So now we'll have to also talk about that, and we'll have you once again talking on Aravalli. Thank you, Professor. Hiteshika, I hope you're well within the timeline proposed by you.
Yes, definitely. Thank you, Dr. Chattopadhyay, and a special thanks to Professor Pant. We have had a truly thought-provoking conversation with you. Your insights, especially onto the role of air pollution in accelerating Himalayan glacier melt and the alarming effects of pollutants creating visible holes on glaciers, were striking. As we wrap up, let's remember that air pollution not only affects us, but the entire world, even the distant spaces high up. As Professor Pant emphasized, tackling it requires both innovation and action. Join us next time as we explore more pressing environmental issues. Until then, take a deep breath and let's strive for a cleaner